Hello and welcome to our lectures on software assurance. In this module, I'll be talking about the SWAMP facility. Our objectives are to understand what is the SWAMP and learn how to use it. In particular, you will learn how to create a project, upload your software packages, run assessments, and view and interpret the results. The examples in this module are in Java. Through the SWAMP can handle programs written in many different languages, such as C, C++, JavaScript, Python, Perl, Ruby, C#, PHP, and others. Let's start with a bit of background. We have a program, and now we want to find weaknesses in that program. Recall from our chapter 1 that a weakness is a flaw in your program that might lead to a vulnerability. To find these weaknesses, we run a code analysis tool, and then we get some results. The problem is that there is no single tool that will report every possible weakness, despite what tool vendors may claim. So it really helps if you use multiple tools to check for different kinds of problems. And each tool will report on the results in a different way, which makes it difficult to compare what the different tools are reporting. To simplify comparing results from different tools, we need tools to speak a common language. The Common Weakness Enumeration, or CWE, can help us in that matter. CWE provides a uniform way to label many common software security weaknesses. This labeling includes a unique number and phrase for each type of weakness. So, CWEs provide a unified way to name software weaknesses. Several assessment tools will include a CWE with each of their weakness findings. This is most common in the commercial tools. As of CWE version 3.0, there are 714 different weaknesses divided into 237 different categories. The information for each CWE includes the numeric weakness ID, a description of the problem, potential consequences of the weakness, examples, and potential mitigations. The CWE framework was developed and is maintained by MITRE. Don't confuse CWE with CVE. The CVE, the Common Vulnerabilities and Exposures, was also developed by MITRE, and it is a standard way to name specific security vulnerabilities that have been found in existing software. It consists of a list of identifiers for publicly known and reported security vulnerabilities. For example, older versions of OpenSSH had the Heartbleed vulnerability, which is CVE-2014-0160. So this CVE will describe the vulnerability and the version of the software to which it applies. Currently, there are over 90,000 CVEs, and more CVEs are reporting each year. Okay, now it's time to get started with learning how to use the SWAMP. SWAMP stands for Software Assurance Marketplace. Its main objective is to make multiple software assessment tools accessible to the user in an automated and easy way. The user doesn't have to worry about getting the tools, installing them, and configuring them, which often can be very time-consuming and complicated. Nor does the user have to worry about keeping the tools up to date. They only focus on choosing which tools they want to run. Most programmers use at most a single assessment tool, and tool vendors really want you to use only their tool. The goal of the SWAMP is to make it easy for programmers to get the benefit from using multiple tools. The SWAMP is free of charge for all users. In addition, the commercial tools that run in the SWAMP are free to use for research institutions and open source projects. As with any software assurance tool, we strongly recommend that you use it throughout the entire software development lifecycle. This means you should be assessing your code from the first moment that you start writing it, through each update and release. The SWAMP project called this idea continuous assurance. The conceptual workflow of the SWAMP is as follows. The Swamp supports multiple tools for multiple platforms. A user uploads their code and builds information to the Swamp. They then assess the code with their chosen tools. When this assessment finishes, the user can see the result using different viewers. Here we see the different tools available in the Swamp for the different programming languages. Note that this list is dynamic. As I speak, more tools, environments, and languages are being added to the Swamp. Before learning how to use the Swamp, let's have a look at some specific concepts and terms that we will be using throughout this module. A package consists of your source code files and build commands to build your program. Several users can share a package. A project contains a list of packages, and it also stores the results of assessing these packages. A project can be shared among different users. An assessment refers to running an analysis tool on a specific package. Again, the result of the assessment will be stored in the project to which the package belongs. The steps we will follow in using the Swamp are the following. First, we will create a project. Then, we will add packages to that project. For adding packages, we have two choices. We can upload a new package, that is, any code we want, or we can use a package that already exists in the Swamp. After that, we will assess the desired packages with the desired tools, view the results of the assessments, and finally, we will interpret the results. Once you understand what is wrong with your code, the next steps are to fix your code and assess it again. The example package that we will use here is a small program with an open redirect weakness, which is CWE 601. The code from our example was taken from the Juliet test suite produced by NIST. The Juliet test suite contains thousands of programs, each with a different weakness. Each program calls two functions, one with the weakness and one with the weakness fixed. These programs are used to test automated assessment tools. In this code, we have a servlet, and we are interested in the lines in red. Basically, in line 15, we get the value of the first cookie, which is not to be trusted since it came from the client, and in line 20, we use that value as the argument to an open redirect. We don't see it here, but right after this code, we have a similar sequence of code with the vulnerability fixed, as I'll explain shortly. Let's refresh a couple of concepts from our Thinking Like an Attacker module. The attack point, which is one location on the attack surface, refers to how an attacker can affect the program. And the impact point, which is one location on the impact surface, is where the attack forces the program to actually make the bad things happen. For CWE 601, the open redirect attack consists of the web application redirecting users to a malicious site chosen by an attacker. The attack point is when the program reaches the value of the first cookie. The impact point is when the send redirect method uses the user-supplied data without performing any validation. One way to mitigate this vulnerability is to use a hard-coded string for the send redirect method. Obviously, this is not always possible. If you can't use a hard-coded string, another way of dealing with this weakness will be to use a wide list of trusted URLs. In other words, only allow the server to redirect a request to a predetermined and non-safe set of web servers. So, we are now ready to use the Swamp. The Swamp is accessible at https://www.mir-swamp.org. You first need to sign up for an account. If you already have a GitHub or Google account, you can log in directly with that account. Also, if you are part of a university that participates in CI Logon in Common, you can use your university account to log in. You can always sign in and create a login and password. But if you already have a GitHub or Google account, you can log in directly with that account. If you are part of a university that participates In CI Logon in Common, you can use your university account to log in. Check the link below to see if your organization is part of In Common. After you have logged in into the Swamp, you will see 6 main options. We'll start here with the Projects option. Here you will see all the projects that you are part of. Right now you don't see any, but we will fix that immediately. We click here to add a new project. We need to supply some basic information about the project we want to create, such as the full name, a short name or acronym, and a description of the project. Then we click on Save Project. Note that on the left-hand side, we always have a menu with the main activities of the Swamp. We'll use the menu in the next step, which is to populate our project with software packages. To add a package, we click here on the package icon. Once you have added a package to your project, you will see them here in the project window. Now we click on Add New Package to create our new package. For the new package, we need to provide its name and description. Then we must specify if the source code for the package is coming from your local computer or from a remote Git repository. In our example, our package is on our local computer, so we need to provide the path name to the source file. The file that we upload can be in several formats, in part depending on the language in which the package is written. In this example, I'm using a .tar file. We also provide the version of the package. Later, when we modify the source code to fix vulnerabilities, we will upload the same package again, giving it a new version number. We can also provide optional version nodes. We click Next, and then you need to provide information about the build process for your program. The build process describes the steps required to compile and link the program. For some programs, such as those with a single source file, this is extremely simple. For others, it can be quite complex. Most software packages should come with build script, a makefile or configuration files. Most of the fields that describe the building process will be filled in for you, but you need to double check that they are correct. In our case, we have the package path, the language is Java, and the program is already in Java bytecode, not Java source code. Some of the Java tools will work with source or bytecode, and some are specific to one or the other. We now click Next to provide information on the build process. In our case, we only include dot in the class path. Finally, we select the project with which our package will be associated, and then click on Save New Package. Here we see details of the packages that we just created. Now it's time to use one or more of the analysis tools to assess our new package. We click on the assessment icon, Run New Assessment. Now we will specify which package we want to assess with which tool or tools. We have a list of packages which include our packages and the Swamp predefined packages. In the tool pop-up menu, we see all the tools available for the language of our package. You can choose all to assess your package with all the available tools. In this example, we selected our package, OpenRedirect 2017, to be assessed with SpotBugs. For some commercial tools like JTest, you will need first to have requested permission to use it. We now click on Save and Run. This will create one assessment run for each tool that you choose. If you are running multiple assessments, they will run in parallel on different virtual machines, each on a different physical machine. A moment ago, I mentioned that you need to have a permission to use commercial tools. How do you request that? Quite easily. The first time you choose a commercial tool for your assessment, for example, JTest, you will get a message like the one on the screen. You click OK, and then you will find yourself on the Permissions tab of My Account. By the way, you can always go there by clicking on your login name in the top right of your Swamp window. You can now click on the permission you would like to request, in this case JTest. A bit more on possibilities for running your assessments. Apart from submitting them directly through the SWAMP website, like we just did, you can use an IDE, Eclipse. In this case, the submission is by pushing the SWAMP button in Eclipse, and view the results directly in an Eclipse code window. Another way to submit jobs is through the continuous integration tool Jenkins. Assessments can be configured to happen with each build or periodically, among other options. The results can be viewed in the Jenkins dashboard. One last option is to submit through a Git SVN repository. In this case, submissions happen with each commit, and the results are shown in the SWAMP. For all of these options, there are publicly available plugins. While I was talking, your assessment was running. You can see in the status column the different stages the assessment goes through. In the screen, you'll see all your assessments. When your assessment appears as finished in the status column, you will be able to view the result of that assessment. For viewing, there are currently two options. The results of the assessment can be seen as a table, this is the native option, or using the CodeX viewer. With the native view, you can get a feeling about the amount and nature of the weaknesses in your program. CodeX is more sophisticated and complicated, allowing you to filter weaknesses based on different criteria, locate the weaknesses in your source code, and keep track of the status of each weakness that you have found. So, to see the result, we select the viewer, we check the box on the right-hand side of the assessment, and we click on View Assessment Results. The first time you request to use CodeX, it will take a while, but viewing results the following times will be faster. The native view is the simplest way to see your results. It provides the results of the assessments in a table. For each weakness that the tool found in your code, you will get the severity, the kind of problem, the line number in the code, and the string associated to the problem. This view allows you to get a feeling about the number and nature of the issues. With CodeX, we have way more flexibility than with the native viewer. In this module, we only use some basic features. We encourage you to explore CodeX more and learn more about its capabilities. In the link shown at the bottom of the slide, you can get more information on CodeX's functionality. On the left-hand side of the screen, we can filter the results using many different criteria. In this example, we are only interested in the security-related issues. On the right-hand side, we have the list of issues, in other words, the weaknesses found by the analysis tool. When we click on the number associated with a weakness, we get details about it. So let's click on the redirect problem. Here we see a description of the problem, and below the line of source code where the tool identified the problem. Let's scroll down the source code. And we keep scrolling down until we see that next to line 50, there's the problem that SpotBugs was reporting. You are likely to use several tools to assess your code. CodeX allows seeing the results of the different tools on the same screen. Here we see that our Open Redirect example program was assessed with 3 tools: FindBugs, JTest, and SpotBugs. And on the left-hand side of the screen, we see the list of issues reported by the 3 tools. We click on a specific issue, and we get the code and the specific line associated with the reported problem. And if we put the mouse on the icon to the left of the line, we see that different tools reported about the same issue. We get the combined output of different tools on the same screen, which is extremely useful. The Open Redirect program is a small and simple example, with few security-related issues and easy to follow in the code. But what happens in the real world, with a large and complex application, when you assess it with a tool for the first time and get thousands of issues reported? We need to go through the list of issues detected by the tool. In the case of the toy program assessed with SpotBugs, the list was small. But in real applications, the list is likely to be long. Here we have in CodeX the result of assessing WebGoat a large system with practical exercises on secure programming, and we see that the code has more than 1,000 issues. Here we need a strategy to deal with the long list of problems. We suggest that you address the most relevant problems first. In our case, we will first focus on the security-related issues and leave problems related to coding style for later. That focus reduces the list of problems. Depending on the tool, we may get information on the seriousness or severity of the issues. In that case, it's worth first checking the issues whose severity is high. And then there is no magic formula. You click on the problem you want to study and determine if it's a real problem. That is, a true positive, or if the tool is giving a false positive. For that decision, you will need to go to the place in the code that the tool associated with the problem and trace back where in the code the involved variables were used. You will need to do that for each issue the tool reports. As I said before, once you have the output of the tool and filter the issues you want to study, you will have to go through the list of issues and determine if they are real problems or false positive. If it's a real problem, then you will have to go back to your code and fix the problem. If it's a false positive, mark it with code EX so it won't be shown the next time you run an assessment on that code. Probably your next version after you fix some of the problems reported by the tool. After you have fixed some of the issues, you will want to upload a new version of the package, associating this new version with the same project. Then you run the assessment again and go back to the first step of this cycle. Let's recap what we have seen in this module. The SWAMP allows easy and free access to multiple tools for software assurance. There is a variety of tools for each programming language, and the use of multiple tools on the same package can reveal different problems. No single tool will find every possible flaw that your program may have. Checking for vulnerabilities in your software should be part of the software development lifecycle. Like we say in the SWAMP, do it early and do it often. And if you are not comfortable with uploading your software or are not allowed to, you can always use SWAMP in a box, a downloaded local version of the SWAMP that you can run in your own facility.